Hey guys, in this video we are going to focus on area and perimeter of plane figures. So we're going to start with perimeter. When you hear perimeter, I want you to think about distance around. So it doesn't really matter what kind of polygon we're talking about. So polygon is just a closed figure that has three or more um, sides, which are determined by line segments. So this is a line segment, this is a line segment, line segment, line segment, and it forms what's called a closed figure, which means there's no gaps or anything in it. So we've got squares, we could have triangles, we could have something with six sides like a hexagon or a pentagon or even a quadrilateral that's not equally sided. Um, it would still be the distance around when we talk about the perimeter. So the different types of figures we could be dealing with, we could be dealing with triangles, which have three sides, quadrilaterals, which have four, pentagons, which have five, and so on. So let's dive a little bit more into triangles. So we could have three different types of triangles. We could have an equilateral triangle. With an equilateral triangle, all the side lengths are the same, and all the angle lengths or angle measurements would be the same. With isosceles triangles, we have two legs that are the same, and it kind of forces these angles to be the same measure. So if a triangle is neither equilateral nor isosceles, then we say it's scalene. We could also talk about triangles in terms of angles. Acute triangles means every angle is less than 90 degrees. A right triangle has one angle that's 90, and then these two would be acute angles. And then an obtuse triangle has one angle that is larger than 90. Which means that the other two would have to be acute. When we talk about quadrilaterals, we're talking about figures that have four sides. So it's a four-sided polygon. And there's different types that we can have. The most common ones are rectangles. We see these all the time. So if you get a box in from Amazon, it's probably going to be in um, um, a box, and each face, each side, is going to be a rectangle. Squares, we see those quite a bit also. That's where every side is the same length. All the angles are 90 degrees in both of these. The difference is that with a rectangle, opposite sides are going to be parallel and they're going to be equal length. So these sides would be equal length and these sides would be equal length. And then we could see trapezoids. So let's talk about those. So a trapezoid is going to have a set of parallel sides. So these two would be parallel here. The difference between this one and this one is that this is isosceles, which means that these angles are going to be the same also. And these angles are going to be the same. And what happens there is it forces this side to be equal to this side. We could talk about a rhombus. Opposite sides are going to be parallel in a rhombus. So this side is parallel to this side, and this side is parallel to this side. And all sides are going to be the same length. So all these sides, this side is equal to this side, is equal to this side, is equal to this side. and then opposite angles are going to be equal. So these angles are equal, and then these angles are going to be equal in a rhombus. So you could think about rhombus kind of like a square that's been kind of distorted a little bit, kind of pushed in a little bit, so it looks more like a diamond shape. A parallelogram is kind of a rectangle that's been pushed in a little bit. Opposite sides are going to be parallel. They're also going to be the same length, so these two sides are the same length. And then these two sides are the same length. And then opposite angles are going to be the same. So those are going to be the same, and then these are going to be the same. And then if it doesn't meet any of that criteria, we just say it's a quadrilateral. So when we talk about the perimeter of any of these types of figures, it really is just the distance around. So the perimeter of a triangle, if we know this distance, and this distance, it would just be the sum of all the sides. Rectangle is going to be kind of the same way. But what's nice with a rectangle is that these two sides are going to be equal and these two sides are going to be equal. So I could simplify this and saying that this is going to be 2L plus 2W, which is where that formula comes from. And if I'm talking about a square, still the distance around, so S plus S 4 times. And because I have 4 of those, it would be 4 times S. So here's another figure. This is a parallelogram. These sides are parallel to each other and they're the same length. These sides are going to be parallel to each other and they're the same length. So if I wanted to find perimeter, it would be B plus S plus B plus S, which we could write as 2B plus 2S. So really similar to how we found the perimeter of a rectangle. So there's your 2B plus 2S for that. So let's look at an example. We want to trim a rectangular frame with a metal strip. The frame measures 30 inches by 20 inches. Find the length of the metal strip you will need to trim the frame. So we know it's rectangular. So it's going to be 30 inches by 20 inches. So if this side is 30, then we know this side has to be 30 also because it's a rectangle. And if this is 20, then this has to be 20. So perimeter is just distance around. So it's 20 plus 30 plus 20 plus 30. Or we could use our shortcut formula, which is 2 times 20 plus 2 times 30. So 40 plus 60, which is going to be 100. So we would need a piece of metal strip that is 100 inches long, and then we could bend it to fit around this, or trim it to fit around that. Let's look at another example. We want to find the length of fencing needed to surround a square corral that measures 60 feet on each side. So here's my square. It's 60 feet on each side. So the perimeter is going to be 60 plus 60 plus 60 plus 60, or 4 times 60, which would be 240, and that's going to be in feet. So we would need 240 feet of fencing to fence that area in. So we could talk about circles. So when we talk about a circle, we usually think about the center, which is going to be right in the middle. We can think about the diameter. The diameter goes across the circle. So this segment AB would be the diameter. Notice it goes through that center. And we could think about the radius. And the radius is the distance from the center out. So this side would be the same distance as this side. That would be the radius. So if this is my diameter, then this would each be considered a radius from the center out, So there's a relationship between these. The diameter is 2 times the radius. Or if I have the diameter and I need the radius, it's going to be 1/2 of the diameter. So suppose the diameter is 8, then the radius, that distance across here is 8, so then the radius would be 1/2 of that, which is 4. So you can see that relationship working there. If I want to find the distance around a circle, I'm thinking about the circumference. And circumference is pi times diameter, or if we know the radius, we could think about it as 2 times the radius times pi. So both of those will give you the same formula. Most calculators will have a pi button on it. If you're using Desmos, you can type in pi for pi. We can approximate it by 3.14 also. So let's look at an example. The bicycle tire has a diameter of 24 inches. How many feet does the bicycle travel when the wheel makes 8 revolutions? So one thing we need to notice here is that the diameter is in inches. They want to know how many feet we're going around. We know that there's 12 inches in 1 foot. So this is equivalent to 2 feet. So if we go around 1 time, that would be the circumference. It would be that distance traveled here. So we've got to figure that out first. Circumference is pi times diameter, which is going to be pi times 2, or 2 pi. And I want to know 8 revolutions. So I'm going to do this 8 times. So it's going to be 2 pi plus 2 pi plus 2 pi 8 times, or 8 times 2 pi, which would be a total of 16 pi. And if I were to type that in my calculator, 16 pi is approximately 50.27 feet. So I would travel about a little over 50 feet in 8 revolutions. So now let's talk about the area. So area is, you could think about area as, let's say I'm looking at a rectangle. And maybe I'm thinking about things in inches. If I were to look at 1 inch by 1 inch blocks, area would be how many blocks it would take to fill in that side. If this is a picture frame, maybe an 8-inch picture frame by the 12-inch picture frame. How many blocks would it take? That's 1 inch by 1 inch. If I were thinking about feet, so if I'm trying to fence in my backyard, and I know the length and the width that I want to fence in, area is how many 1 foot blocks it would take to fill in that entire space. Area of a rectangle is length times width. So let's look at an example. How many square feet of sod are needed to cover a football field? And a football field measures 360 feet by 160 feet. So here's 360 and here's 160. So area is length times width, which is 360 times 160. A lot. 57,600 is what I got. And units for area is going to be square, so this is in square units. So we would need 57,600 square feet of sod to cover that entire football field. We're talking about a square. All the sides are the same length. So remember, area is length times W, but because they are all the same, we could think about it as side squared. A homeowner wants to carpet the family room. The floor is square, so we know what it looks like, and it measures 6 meters on each side. We want to know how much area is going to need to be purchased. So it's going to be 6 times 6, which is going to be 36 square meters. Area of a parallelogram. Remember, parallelogram has parallel sides here and here, and then these opposite angles are the same measure. So the area of a parallelogram is given by base times height. So this would be my base, and my height is when I drop a perpendicular down to that base. Let's look at an example. A solar panel is in the shape of a parallelogram that has a base of 2 feet and a height of 3 feet. We want to find the area. So let's draw a picture. So my base is 2 feet and my height is 3 feet. And these pictures are not drawn to scale, and that's okay. It's just giving us an idea of what it looks like. So it's area of the base times the height. So base times the height would be 6. And this would be in square feet. And the reason the square feet is because this is in feet and this is in feet. And when I multiply feet times feet, I would get feet squared. So those units are always going to come out of whatever that formula is. Area of a triangle is 1/2 base times height. Again, that height is dropping a perpendicular down to that base. So we would say this side is the base. So a riveter uses metal plates that are in the shape of a triangle with a base of 12 and a height of 6. We want to find the area. So area is 1/2 base times height. So it's going to be 1/2 of 12 times 6, which is going to be 36. And these units are both in centimeters. They do have to be the same units to be able to multiply these together. So my area is going to be in centimeters squared. So I've got a trapezoid. Area of a trapezoid is really dependent on the height and then the sum of the bases. So it's going to be 1/2 of the height times the sum of the bases. Don't forget that 1/2. That's important. A boat dock is built in the shape of a trapezoid, and it does not matter if it's a trapezoid or if it's an isosceles trapezoid. The area is going to work the same. The bases are 14 feet and 6 feet with a height of 7 feet. We want to find the area. Area is 1/2 of height times base 1 plus base 2. Okay, notice that parentheses there. That's important also. So it's going to be 1/2 times 7 times base 1 plus base 2. And it does not matter which one I call base 1 and base 2. Because 6 plus 14, if I do it the other way, it's going to be 14 plus 6, and they both add up to the same thing. So that's going to be 70. That's going to be in square feet again. Area is always in square units. We talk about area of a circle is pi r squared. Find the area of a circle with a diameter of 10. So let's draw a picture. So we know the diameter, which is going through the center, is 10. We know area is pi r squared. If the diameter is 10, the radius is half of that, which is 5. So my area is going to be pi times 5 squared. So it's going to be 25 pi units, which would be meters. Or we could type that in the calculator. And 25 times pi is about 78. And that's going to be, oops, that's in square meters because it's area. We would square that 5 meters here to give us that meter squared. So that's how we would find the area and perimeter of different figures.